Let us continue foundation chemistry. Here we'll see isomers. We'll see. Now, in the isomers, we'll take one formula CnH2nO. CnH2nO. Now, CnH2nO in the sense, now n is equal to 2 we will substitute, or n is equal to 3 we will substitute. N is equal to 3. What we are getting means C3H6O. Here, 3 carbon atoms are there. 1, 2, 3. One oxygen is there. That one oxygen I will write in the form of aldehyde. Then I will give carbon, carbon, single bond I will give, hydrogens I am giving. So here what I am getting means CH3, CH2, CHO. This is called aldehyde. Here what is the functional group present? Aldehyde. Then 3 carbons I will write like this. Then oxygen I will write for center carbon. For this carbon I will give 3 hydrogens. For this carbon I will give 3 hydrogens. Now here what is the functional group present? Ketone. So aldehyde functional isomer is ketone. Now you see these two. These two have same molecular formula, that is C3H6O. But functional group is different. Therefore these two are called functional isomers. Generally for aldehyde, what is the functional isomer means ketone. For ketone, functional isomer is aldehyde. It is general. So now we will take the formula. N is equal to, we'll take suppose 6. N is equal to 6 we will take. Substitute in this formula, general formula, we will get C6H12O. C6H12O. Now what are the aldehydes and what are the ketones possible for this? That we will see. Okay. So 6 carbon atoms are there. So we will write 6 carbon atoms straight. 1, 2, 3, 4, 5, 6. At 6th carbon we will make that as aldehyde. Then this last carbon we will write at this place. Otherwise at this second carbon. Last carbon we will bring to second position. 1, 2, 3, 4, 5. So last carbon we brought to second position. This carbon we will bring to third position. 1, 2, 3, 4, 5. That carbon we are bringing to which position means third position. This carbon will bring to fourth position now. 1, 2, 3, 4, 5. Fourth position will bring. Okay. Now next what shall we do in the sense? This last carbon in this second compound, this last carbon we will bring to this second carbon. Now we will write 1, 2, 3, 4. 4 carbons. Already at second carbon branch 1 carbon is there. This last carbon we will take as a branch for second carbon. Okay. Next what shall we do means, this carbon we will bring as a branch for this third carbon. Then we will bring both branches to the third carbon. Both branches to the third carbon, like this we brought. So we have written for aldehyde these many isomers we have written. Sir, this is number 1, 2, 3, 4, 5, 6 and 7. 7 isomers we have written for aldehyde. For aldehyde we have written 7 isomers. Let us give hydrogens now. For this carbon give 1 hydrogen, sorry 3 hydrogens, here 2, here 2 hydrogens, 2 hydrogens, here 2 hydrogens, here 3 hydrogens, 2, here 2, here 1 hydrogen we have to give, here 3 hydrogens we have to give, here 3 hydrogens, here 2, here 1, here 3, here 2, here 3 hydrogens, here 1 hydrogen, here 3 hydrogens, Here 2 hydrogens, here 2 hydrogens. Here 3 hydrogens, here 2 hydrogens, here no hydrogen because the carbon is having 4 bonds, therefore no hydrogens. Here 3 hydrogens, here 3 hydrogens. This carbon is having 1 bond, therefore make it as 4 bonds for giving 3 hydrogens. So here 1 hydrogen, here 3 hydrogens, 3 hydrogens, here 1 hydrogen. Then in this case 3, 3, 3, here don't give hydrogen because it is having 4 bonds. Here 2. Okay, we have given. Now let us say the name. Here 6 carbon atoms are there, therefore root word is X, primary suffix is An. Aldehyde is the functional group, for that secondary suffix is An. For this, at second carbon methyl group is there, therefore 2 methyl we can say 2 methyl. So parent chain contains 5 carbon atoms, therefore root word is pent, primary suffix En, secondary suffix is Al. Okay, next here at third carbon branch is there, therefore 3 methyl we can say 3 methyl. Parent chain contains 5 carbon atoms, therefore root word is pent, primary suffix is En because carbon carbon single bond, secondary suffix is aldehyde, aldehyde first 2 letters Al, that is secondary suffix. Here branch is present at a fourth carbon, therefore we can say it is 4 methyl. Parent chain contains 5 carbon atoms, therefore pent, primary suffix is En, secondary suffix is Al. Here branch is this is one branch methyl, it is one branch methyl. How many branches are there? Means 2 branches, therefore we have to say dimethyl, we have to say dimethyl. Okay, now this methyl group present at second carbon of parent chain, therefore position is 2. This branch also present at second carbon of parent chain, therefore we will write 2 comma 2, we will write 2 comma 2 dimethyl. Parent chain contains 4 carbon atoms, therefore but we can say primary suffix En, secondary suffix Al. Why secondary suffix Al? Because functional group is aldehyde, therefore secondary suffix is Al. Okay, here branch is methyl group. How many branches? Means 2 branches, therefore we will say dimethyl, we will say both are methyl group only. This methyl is present at second carbon, this methyl is present at third carbon, therefore we can say 2 comma 3 dimethyl. Then parent chain contains 4 carbon atoms, therefore root word is but, primary suffix En, secondary suffix Al. Okay, then for this name, here 2 branches present, that both branch same name, therefore we will say dimethyl, we will say. Next parent chain contains 4 carbon atoms, therefore but, primary suffix En, secondary suffix Al. And what is the numbering? What is the position of branch? See that, give the numbering such that functional group should get least position. Therefore number 1 for aldehydic carbon, number 2 for this carbon, number 3 for this carbon, therefore branch position is 3, therefore we have to say 3 comma 3 dimethyl butanol. Now say which are chain isomers and which are position isomers, you say. Now chain isomers means what? Parent chain length different, parent chain length is different. Parent chain length is different means what? Parent chain should contain different number of carbon atoms. Now number 1 contains 6 carbon atoms in the parent chain, 2 3 4 contains 5 carbon atoms in the parent chain, 5 6 7 contains 4 carbon atoms in the parent chain. Therefore 1 with rest are called which isomers? 1 with rest are called which isomers? We will say 1 with rest, we can call it as chain isomers, we can call. Why? Because chain length is different. In the number 1, the parent chain contains how many carbon atoms? 6 carbon atoms. Number 2 contains, in number 2 parent chain contains how many carbon atoms? 5 carbon atoms. So in number 1 and number 2, parent chain number of carbon atoms different, therefore number 1 and number 2 are called which isomers? Chain isomers. Like that 1 and 3, 1 and 4 are chain isomers. Now 1 and 5 you see, in the number 5 compound, parent chain contains how many carbons? 4 carbons. But in number 1, 6 carbons. Therefore parent chain length is different in number 1 and number 5. Therefore number 1 compound and number 5 compound are which isomers? Chain isomers. Like that 1 6, 1 7 are chain isomers. In that way 2 and 5 you see, 2 and 5. In number 2 compound, parent chain contains 5 carbons. In number 5 compound, parent chain contains 4 carbons. Therefore compound 2 and compound 5 is having different parent chain length. Parent chain length is different in number 2 and number 5 compound. Therefore, compound 2 and compound 5 are chain isomers like this: 2 6 2 7, 3 5 3 6 3 7, 4 5 4 6 4 7. All these are what? Chain isomers. Okay, then number 2 compound we will take, number 3 compound we will take. In number 2, what is the position of this branch methyl? 2. In compound 3, what is the position of branch methyl? 3. So position of methyl is 2 here, position of methyl is 3 here. Therefore, these two are which isomers? Position isomers. So 2 and 3 are position isomers. What about 3 and 4? Position isomers. 2 and 4 position isomers. Then compound 5 and compound 6, you see, in compound 5 position of branch is 2 comma 2, in compound 6 position of branch is 2 comma 3. Therefore, compound 5 and compound 6 are position isomers. 6 and 7 we will see. In compound 6 position is 2 comma 3, in compound 7 position is 3 comma 3. So 6 and 7, compound 6 compound 7 is having different positions. Therefore, 6 and 7 are position isomers. What about 5 and 7? Shall we say position isomers? Yes. Therefore, for aldehydes we said what in the sense chain isomers and position isomers we said. Okay. So we have written these many isomers as aldehyde. Aldehyde isomers we have written for this general formula. Here, what is the general formula? C6H12O. For this general formula, how many aldehydes we have written in the sense so and so number of isomers we have written. Then for this compound, for this general formula, ketone is possible. What are the possible ketones that we will see? What are the possible ketones that we are seeing? Now 6 carbons are there in the given formula. That 6 carbons we will write like this: 2, 3, 4, 5, 6. Ketone we will write here. Okay. Next, 6 carbons we will write straight: 3, 4, 5, 6. Write ketone at third carbon. Okay. That's all. Ketone we have position we have said. Now write 4 carbon and write 5 carbon atoms in a straight. 5 carbon atoms. Ketone give at second position. Remaining 1 carbon you give here. Okay. Then this branch you write at this carbon now. So 5 carbons we are writing: 3, 4, 5. That carbon we are writing here. Branch we have written here. Next, what we have to do means write this carbon, this terminal carbon at this carbon as a branch. Write the terminal carbon at this carbon as a branch. Therefore, 1, 2, 3, 4. Here ketone. Here 1 carbon already is there. Now you write this carbon as a branch of this carbon. Okay. So we have written possible isomers of ketone we have written. Now we will give hydrogens. So how to give hydrogens means see such that carbon should get 4 bonds. So how many bonds are there you see? Remaining how many bonds are required for getting 4 bonds you see? So how many bonds are required for getting 4 bonds? That many hydrogens you give it. So first compound, this carbon is having 1 bond. So it is in need of 3 more bonds to get 4. Therefore you give 3 hydrogens. For this carbon already 4 bonds are there. Don't give any hydrogens. For this carbon 2 hydrogens, 2 hydrogens, 3 hydrogens. Next, here 3 hydrogens, here 2 hydrogens, here 2 hydrogens, here 2 hydrogens, here 3 hydrogens. Here 3 hydrogens, here 1 hydrogen, here 3 hydrogens, here 2 hydrogens, here 3 hydrogens. Then this carbon 3 hydrogens will give here 2 hydrogens, here 1 hydrogen, here 3 hydrogens will give here 3 hydrogens. For this carbon 3 hydrogens, for this carbon 3 hydrogens, for this carbon 3 hydrogens, here 3 hydrogens. Don't give hydrogens to this carbon. Why? Because this carbon is having already 4 bonds. Okay, sir. Now let us say the name. Here straight chain contains 6 carbon atoms, therefore X. Primary suffix is N, secondary suffix is ketone. Ketone last 3 letters O. Now position of ketone is second position, therefore 2 we can say. We are giving numbering from left side. Here first carbon, it is second carbon, like this we are giving numbering because ketone carbon should get least position. Therefore we have started numbering from left side, not from right side. Okay. Here parent chain contains 6 carbon atoms. Therefore, we can say the name is X. Primary suffix N, secondary suffix is one because functional group is ketone. This position is 3. Then here we will see this branch, this methyl is branch. Therefore, we will say methyl. Parent chain contains 5 carbon atoms. Therefore, pent primary suffix is N, secondary suffix is one. How to give numbering in the sense see such that this ketone is a functional group. This carbon should get least number. Functional group carbon must get least number. Therefore, start giving numbering from left side. Therefore, here number 1, here number 2. So ketone position is 2. Then here number 3, branch position is 3. Therefore, 3 methyl. Next here we will see the branch is methyl group. Therefore, you write methyl. Parent chain contains 5 carbon atoms. Therefore, pent primary suffix N, secondary suffix 1. Numbering from which side shall we start? Left side or right side? Left side shall we start? Yes. Why left side? Because ketone carbon will get least position. Don't start from right side. Don't think about methyl group. Think about ketone group. Ketone is the functional group that must get least position. Therefore, give start to give numbering from left side. Don't start from right. Therefore, start from left. Here number 1, here number 2. So ketone present at second carbon. Then it is number 3, it is number 4, branch present at number 4. Then here 2 methyl groups present as a branch. Therefore, we can say here dimethyl. We can say we are saying this is as a dimethyl, and parent chain contains 4 carbon atoms. Therefore, but. Parent chain contains 4 carbon atoms. Therefore, but we have said primary suffix is N, secondary suffix is one. Now let us give position. This carbon is getting second position. Therefore, ketone position is 2. The branch position is 3. Therefore, 3, 3 dimethyl. Like that we have written. For aldehyde, how many isomers we have written? 7 isomers. Now we will come for ketone. Now we will say it is 8. This is 9th compound. It is 10th compound. It is 11th compound. It is 12th compound. Okay. So for ketone, we have written 5 isomers. We have written. For ketone, 5 isomers we have written. For aldehyde, already we have written 7 isomers. Now we will see which are chain isomers here. That we will see. Which are chain isomers. Chain isomers means what? I said parent chain length is different. That means parent chain should get different number of carbon atoms. Now you see number 8, compound 8. Parent chain contains 6 carbons. 9 and 10. Parent chain contains 6. 9 is in the 9 parent chain contains 6 carbons. In the 10 parent chain contains 5 carbons. In the 11 parent chain contains 5 carbons. In the 12 parent chain contains 4 carbons. So parent chain length is different means chain isomers. Now you say which are chain isomers? Shall we say 8 and 10, 8, 11, 8, 12, like this 9, 10, 9, 11, 9, 12. Yes. Then is there any more chain isomers? Yes. Which are? We can say 10, 10, 11, 10, 12, 10, 12 we can say. 10, 12. Then we can say 11, 12. 11, 12 also we can say chain isomers. Next we will see position isomers. Now, in compound 8, position of ketone is 2. In compound 9, position of ketone is 9. Therefore, 8 and 9, in the compound 9, position of ketone is 3. So, compound 8, compound 9, position of ketone is different. Therefore, 8 and 9 are position isomers. Okay. Then, compound 9, position of ketone is 3. Compound 10, position of ketone is 2. Therefore, 9 and 10 are position isomers. 9 and 10 are position isomers. Then, 9 and 11, position isomers. 9 and 12. Now, 9 and 11. What isomers do you know? Chain isomers as well as position isomers. 9 and 11, 9 and 11 we can say chain isomers as well as position isomers. Why? Why chain isomers? Here 6 carbons, here 5 carbons. Therefore chain isomers. Why position isomers? Ketone position is 3. Ketone position is 2. Therefore, position isomers. So 9 and 11 are chain as well as position isomers. Okay. Then, like that, any other example do you want to say? What about 9 and 12? Chain isomers as well as position isomers. 9 and 12. Sorry, okay. Then any other like this chain as well as position. Like that, any other example is there? Chain as well as position. Shall we say uh, chain as well as position in the sense can we say 11 and 12? 11 and 12. Yes. Because here 11 parent chain contains 5 carbon atoms, 12 parent chain contains 4 carbon atoms, therefore chain isomers. In 11, position of branch is 4. In 12, position of branch is 3. Therefore, 11 and 12 chain isomers as well as position isomers we can say. Next, these are ketone. From 8 to 12 ketone. From 1 to 7 what? Aldehyde. Therefore, this 1 to 7 and this 8 to 12, which isomers? Functional isomers. Why? 1 to 7 functional group is aldehyde. 8 to 12 functional group is ketone. Therefore, 1 to 7 and 8 to 12, these are functional isomers, because in 1 to 7 functional group is aldehyde, 8 to 12 functional group is ketone. Therefore, these are functional isomers we can say. Suppose I am taking number 12. I am taking number 12. Then I am taking a number 1. This number 1. Number 1 I am taking. 12 and 1 I have taken. Compound number 12, compound number 11. These are coming under which isomers means what shall we say? Chain isomers will say, position isomers will say, then functional isomers will say. Okay, sir. Next, is there any more isomers? Is there any more isomers possible? Yes, still more isomers possible. What is that? Now you take 9, 8th compound and 9th compound you take. In 8th compound, functional group is ketone. 9th compound, functional group is ketone. In 8th compound, left side, methyl is there. In 9th compound, left side, ethyl is there. In 8th compound, right side, N-butyl is there. In 9th compound, right side, propyl is there. Therefore, functional group on either side groups in these two cases different. Therefore, these two are which isomers? Metamers. Metamers means what? Functional group on either side, alkyl group should be there, like this, methyl, ethyl, propyl, like this. It is a functional group. On either side, alkyl groups are there. Here methyl and butyl. Here functional group on either side, what isomers are there? Ethyl and propyl. Therefore, then here left side should be different. Here right side should be different. Otherwise, at least one is different. At least one means left side alone or right side alone or both. Is there means we can say metamers, we can say. Like this, which and all metamers can you say? Now, see 9 and 10. 9 and 10 are metamers. 10 and 11 are not metamers. 11 and 12 are metamers. 11 and 12 are metamers. Okay, we have said metamers. For aldehydes and ketones, another isomer also possible. Another structural isomer also possible. What is that means? Tautomerism, that is possible. So now what is tautomerism, that we'll see. For that we'll take one simple example and we'll see. We'll take acetaldehyde and we'll come for what is meant by tautomerism. Acetaldehyde formula is what means CH3CHO. This acetaldehyde contains 2 carbons. The 2 carbons I have written. Then it is having functional group. What is the functional group? Aldehyde is a functional group. That aldehyde functional group I have written. Then this carbon is having 3 hydrogens. That 3 hydrogens we have written. It is acetaldehyde. This acetaldehyde will go for tautomerism. How? In the sense, this oxygen is more electronegative than this carbon. Oxygen electronegativity is 3.5, carbon electronegativity is 2.5. So oxygen is more electronegative than carbon. Therefore, this pi bond will shift to oxygen. Why? Because oxygen is pulling the pi bond with more tendency than carbon. Then due to deficiency here, how deficiency? Because this bond is migrating to oxygen. Therefore, this carbon is getting deficiency. In order to satisfy that deficiency, neighboring carbon is called alpha carbon. That bond is shifting like this. Therefore, what is happening? This CH2 no change, that no change. Here, this CH also no change. This O we will write. Now, what is the change? You will see the single bond will become double bond. Why? Because this bond comes to this place. This double bond will become single bond. Now this oxygen is gaining this bond, therefore negative charge. This hydrogen is losing the bond, therefore positive charge. Here positive charge, here negative charge, therefore the positive ion goes to this negative charge. Therefore we will get what in the sense this CH2, a double bond CH. This O minus is making bond with this H plus, therefore becoming OH. Here double bond is there, therefore ene. Double bond means CC, double bond means ene. Here alcohol is there. Alcohol means last two letters OL. This OL first letter is vowel sound. Therefore, we'll drop this E. Therefore, we'll say this name is Enol. It is Enol. It is containing aldehyde. Therefore, it is aldo. We will say aldo. Therefore, this is aldo group. It is Enol group. Here and here, what is the difference? In these two, what is the difference? Means position of hydrogen is different. Hydrogen is attached to carbon. The same hydrogen is attached to oxygen. Therefore, position of hydrogen is different. Therefore, this is called a tautomers. Tautomers. This phenomena is called tautomerism. So, this aldo and enol are tautomers. Therefore, it is called aldo enol tautomerism. We will say these are aldo enol tautomerism. This is aldo enol tautomerism. So for aldehyde, what is the tautomer? Enol. For enol, what is the tautomer? Aldehyde. In some cases, for enol, ketone also a tautomer. Then we will say keto enol tautomerism. That we will see. We will take acetone. We are taking acetone. This acetone formula is CH3CO CH3. CH3CO CH3. This CH3 I will write. CH3 I have written like this. CO I will write like this. CH3 I will write like this. So what happens here? We'll see. This oxygen is more electronegative than carbon. Therefore, this bond is shifting here. Therefore, this carbon is getting deficiency. The neighboring carbon is called alpha carbon, that is giving the bond. Okay. Therefore, we will get here CH2 will be there. This hydrogen is losing the bond, therefore getting plus charge. This single bond becomes a double bond. This double bond becomes single bond. This double bond becomes single bond, and O gets a negative charge because this pi bond is shifting to oxygen. Then this single bond will write, then CH3 will write. Then this H plus goes to this O minus. Now see, shall we call this as enol? Yes, because a double bond is there, OH group is there. Shall we call this as ketone? Yes, ketone. Ketone in the sense keto we have taken. The first 4 letters we have taken from keto. Now this keto, enol, keto group and enol group, you see position of hydrogen is different. You see hydrogen is attached to carbon, the same hydrogen is attached to oxygen. So position of hydrogen is different, therefore these two are called tautomers. These two are called tautomers. This phenomenon is called tautomerism. Here which are in tautomers means keto and enol, therefore it is called keto enol tautomerism. Therefore, so tautomerism is possible for ketone and tautomerism is possible for aldehyde, for which what is required for ketone and aldehyde, what is required means alpha hydrogen is required. What is alpha hydrogen? That means we'll go to alpha carbon. What is alpha carbon? The carbon which is directly attached to the functional group aldehyde or ketone, that carbon is aldehyde, alpha carbon. Now we'll take, first we'll see the ketone here. It is a ketone. Now this carbon is directly attached to ketone carbon, therefore it is alpha carbon. This hydrogen is directly attached to alpha carbon, this is therefore it is alpha hydrogen. So if alpha hydrogen is there, then only tautomerism is possible for ketone. What about aldehyde? Same. This is aldehyde. This aldehyde group. This carbon is directly attached to aldehyde group, therefore it is alpha carbon. This hydrogen is attached to aldehyde carbon, therefore it is alpha hydrogen. So if alpha hydrogen is there in aldehyde and in ketone, then we can say tautomerism is possible. So for aldehyde and ketone, what are the isomers possible? Chain, position, functional, metamerism, tautomerism. These are possible for aldehyde ketones. For aldehydes and ketones, these are the possibilities. Okay. Like this, we can say isomers, we can say. Then if we say these are, so far we have discussed structural isomers, we have discussed. In the previous class we have discussed for aldehyde and ether, aldehyde and ether. Now we have discussed for aldehyde and ketone. Like this, many isomers are there. Like this, many sets are there. If we take carboxylic acid, for that ester is the isomer. Carboxylic acid. Now how we are saying for alcohol ether, for aldehyde ketone, like this. For carboxylic acid, what we can say means ester we can say. Next we'll see. Next I will give one set I will give that comes under which category you say. Now I will take or NH2, like this I have given. Here this is called primary amine. Here functional group is called primary amine. Next I will give or NHR, like this I will give. This is called secondary amine because this amine contains nitrogen that is attached to two alkyl groups, two R groups, therefore it is called secondary amine. Next I will give here one R group, here one R group, here one R group. This functional group nitrogen is attached to three alkyl groups, therefore it is called tertiary amine. Now you say in the first compound the functional group is primary amine. In the second compound the functional group is secondary amine. In the third compound the functional group is tertiary amine. In these compounds what is different? Functional group is different, therefore these are functional isomers. Functional isomers we can say. Now for these functional isomers we can write chain isomers, position isomers, then metamers also we can write. Can you say metamer is possible for which case? Metamer means how metamer means first what condition should be there? The functional group should have at least two alkyl groups on either side of it. Now you see this one, is it a functional group? Is it having alkyl group on left side? Is it having alkyl group on right side? Is it having minimum two alkyl groups? on either side. Therefore, it can show metamers. What about this one? Can it show metamers? Yes. The functional group is having 3 alkyl groups. Minimum 2 only we need. But here 3 is there. Therefore, it can show metamers. Metamerism is possible. Okay, sir. So, primary, secondary, tertiary amines we are taking. For this, we are writing what in the sense we are able to write chain isomers, position isomers, metamerism, functional isomers. These and all we can write. Sir. Now we will take RCONH2. This is called amide. This functional group is called amide. This is primary amide, we can say. Next, see. RCONHR. This we will call it as secondary amide. Then RCONR3. NR2. This is called a tertiary amide. Now, primary amide means CONH2. N should have 2 hydrogens. Then primary amide. Secondary amide means CONHR. N should have only 1 hydrogen. Secondary amide. Tertiary amide means CONR2. N should have no hydrogen. N is not having hydrogen. Then it is tertiary amide. So primary amide, secondary amide, tertiary amide. These also we can say functional isomers, we can say. Sir. Here chain, position, functional, metamerism, these and all possible. Next we will take. Now we will take what in the sense? We will take cyanide. We will take. What is the formula for cyanide? Cn minus. What is the structure of cyanide? Cyanide contains carbon and nitrogen. Carbon, atomic number 6. Electronic configuration 2, 4. So outermost shell contains 4 electrons. 1, 2, 3, 4. Nitrogen, atomic number 7. Electronic configuration 2, 5. So outermost shell contains how many electrons means 5 electrons for nitrogen. 1, 2, 3, 4, 5. Now let us give bonding. 1, 2, 3. Bond we have given. Then this negative charge we have to give to carbon. Why? Because carbon valence shell contains 3 bonds and this electron. 3 bonds means 6 electrons. This electron means 7th electron. So this carbon is having 7 electrons only. 7 electrons means less than 8 octet. Less than octet. Therefore electron deficient. So give negative charge. Negative charge means additional electron you give it. So now this carbon is having 8 electrons. Therefore octet. Nitrogen already having octet. So cyanide Cn minus means negative charge you have to give to carbon. In the cyanide, negative charge you have to give to which one? Carbon you have to give. For this cyanide, what is the functional isomer means? Isocyanide. For cyanide, functional isomer what is means? Isocyanide. Isocyanide formula is what means? Cn minus, Nc minus. Cyanide Cn minus, isocyanide means Nc minus. These two are functional isomers. Like this, we'll see another one. Thiocyanate, SCN minus.